Good morning. This is Al Koritz, Applications and Service Manager at Electron Microscopy Sciences. Today I'd like to discuss and show you my protocol for sputtering oxidative metals in the Q series coating systems by Quorum. This video only applies to turbopump systems. Rotary pump systems do not have the adequate vacuum requirements necessary to successfully sputter oxidative metals. In this case, we will be showcasing aluminum. These are 3 targets which I've previously used in the Q300. As you can see, there's a very nice clean racetrack. You can see the crystalline structure of the sputtered aluminum. Once prepared and sputtered, I keep these systems, sputter targets, in an inert gas cabinet, or at least a cabinet with dry rite to keep the water vapor content and oxygen level low. So these targets do not get coated with oxide and are relatively quick to put back into service if necessary. This target has been kept out of an inert gas cabinet and is heavily oxidized and minimally used. This is usually what they look like out of the package. These need preparation before you install them in your sputtering tool. So that's what I will show you today. First, let me put these back in their bag so I can put them back in the inert gas cabinet where they're stored. You need to abrade the surface and remove as much oxide as possible before installing them in the unit. And my usual mode of operation is I use standard materials preparation grinding discs. This is 240 grit with a stick-on backing. This way the material will stay put on the bench top and I can easily peel it off. The next thing that you'll need is some distilled or deionized water, which I wet down the surface of the grinding material. And then sometimes I will get some melt mount, which is a common materials substance which you can heat up to a specific temperature, and usually what I'll do is I will stick a SEM stub which I don't have here at the moment, but to act as a handle, because grinding these on the surface can be somewhat difficult because they have this tendency to stick and adhere, and it makes polishing them all the more difficult. Right now I've got my nails sort of over the edge. So all you do is you grind them on the surface, and you can see some material is being removed, and you do this until you get through most of the oxide and you have a relatively shiny surface of aluminum to work with. All right, after a little polishing and grinding, we got a lot of the oxide off the target, and it's ready to be sonicated in some ethanol or IPA, just to make sure that we get all the little grits out of the tiny crevices and scratches we created. And then we'll mount it in the sputtering system. Once the targets are installed, you need to set some parameters in your coating tool. It doesn't matter whether it's a Q150 S system, a Q150 VS system, a Q300 TD, or a Q300 TT, like the one I'm working with here. They all take similar parameters in order to sputter aluminum. So here we have a multi-target aluminum recipe. So we'll press the down arrow on this particular tool. This will depend on what display you have, whether you have an old display or a plus display, which is the current standard on the instruments being sold. This one was set up for 100 nanometers of aluminum, but you can set the termination thickness to what you want. We brought it up to one of the highest value of sputter current we could, which the max is 420. Maximum sputter time is 60 minutes. Flush chamber, yes, you want to flush the chamber because you want to flush out as much room air as possible. Once you get in there, tooling factor we're not going to deal with. Clean target, yes. There is an automated series of computer controlled cleaning that takes place. It measures sputter current versus voltage, and when the voltage drops to a particular point, then it considers the target clean. If the target is not clean, according to the machine, it will just keep cycling through the target cleaning cycle. Gas bleed time, I changed to the maximum, which is 60 seconds. You can up the cleaning current if you want to get this to go faster. 200 is the max cleaning current. Operational vacuum you don't play with. Bleed gas flush cycles, you can increase that. I generally only do one. Bleed gas vacuum, that is what I consider to be the optimal pressure to backfill with argon to get high quality aluminum coatings. Cleaning time 30 seconds, that's default. You may want to increase that. Vent time and chamber outgas time are pretty much factory set. This particular system is set up on a production level password, which none of you get to have because the highest level password I can give you is a admin password. This allows me as an engineer to make changes that would be somewhat detrimental if you didn't know exactly what you were doing. So those are the parameters, no matter what the system you have would be. The sputter current for single target instruments would be much lower than this. I believe the maximum is 150 milliamps. because this is a 3-target system, it's 420 milliamps. So just be aware of that difference. Now we're in the 300 TT's history files, which records all the different processes run on the system, stores them so you have access to this data. This is an aluminum process for basically 100 nanometers. Here's the very beginning of the process. It clears the backing, it flushes the system, vents, roughs the chamber, waiting on turbo pump, bleed flush, this process time, pump down 2, outgas chamber. All these are to get rid of any residual gases in the chamber. Over here it shows you the vacuum achieved, and then it shows cleaning target and the voltage and currents involved in that. 350 volts approximately at 150 milliamps, so that's cleaning target. Weighting plasma, it's going through its multiple target A, target B. Considers target A cleaned at this point, so it switches to target B. It does the cleaning process, then switches to target C, waits delay, cleans target C again, waiting plasma. Now it gets in the coating routine, and we start coating. We can see the deposition rate going up and up. We get to 99.99 nanometers, stops the turbo, vents. The rest is relatively uninteresting. In the history menu, you can also have a process view. It gives you the overview of all your parameters. Message view is not really that interesting. It just tells you what the end result was. If you're using a plus system and you do not have an aluminum sputter process on here, you can easily make one. Again, I'm in production level mode, so you choose the type of sputter process you want. Let's go with FTM terminated. Usually I just put the material and the process. I don't put the thickness because it's so quick and easy to change the thickness. You don't need to load your system menu up with a whole bunch of processes that that you have to sort through. So here we are. We can set the sputter current. Well, let's take a step back. Let's change the material. This one doesn't have. Here we are, aluminum. It's setup process using material data. Yes. It automatically sets the basics for your sputter process. We're going to change it quite like what I showed you on the 300 TT. This is a dual head 300 TD system. So since we're only sputtering with a single sputter head, it went to the max. Aluminum tooling fabric, we're not going to play with that. Flush chamber, maximum sputter time. You change this depending on your thickness of coating. Some people that want, 100 nanometers, that takes quite a bit of time, even at maximum power. but we're not going to change this. 4 minutes is adequate for 5 nanometers of aluminum. Maximum sputter time. Flush chamber, yes, of course we want to get as much oxygen out of there. Pump hold is always important. If you want good quality aluminum sputtering, you need to allow the chamber to evacuate for at least 60 minutes to get as much of the water vapor and room air out of the chamber as possible. Otherwise, you're just creating oxides. So this is page 1 of the menu. Gas bleed time. I always will increase this to the maximum. Oops. Okay, 60 seconds. This allows the argon to become more homogeneous atmosphere in the chamber. The bleed vacuum for aluminum, as I said, I prefer 5 times 10 to the minus 3, so 0.005 should do it. By the way, if you see a circle with a line through it, it means that that is no longer a default process. When they're just dark like this, means that it's a default factory process. You can increase the clean time if you wish. Vent time is as needed. Cleaning current, it goes to the max because it's a single head system. And that's just stage rotate. So that's how you would set it up on your single target system. I did not choose a multi-target, multi-layer process, which the 300 TD is capable of doing, but I just wanted to show you how to set a process up from scratch. That concludes this instructional video. I am not going to go through the actual process of sputtering aluminum. I don't normally do it. Usually it's done in the 300 TT because once aluminum gets on your glass bell jar, it's very difficult to remove, and I only sort of use one system for sputtering aluminum. If I need to only sputter single target aluminum, you can do that on the 300 TT by selecting just one of the targets to function. So again, that concludes this video.